Hi friends! So normally I have a silly intro for you today, but instead I have something even better. I have a special guest. Would you like to introduce yourself, special guest?
Hi friends, I am Mr. Volel's mommy.
Yay! Hi mommy, so happy to have you.
And so happy to be here.
Yes, you're never too old to call your mommy mommy. So, today we're going to start talking a little bit about how we go about writing those linear equations into variables from last time in what we call their quote-unquote standard form. So the title of our lesson today, Class 2 of Unit 4, let's talk about linear equations in standard form, whatever that means. Part 1. And to get us into it, here's a bit of a warm-up for you. Mommy, would you like to read the warm-up?
Sure. Example. In the Earth Kingdom capital of Ba Sing Se.
Do you know what this reference is?
No.
No?
What is it about?
Avatar: The Last Airbender?
Ah, yes, I know the last
Very good.
Airbender.
Okay, keep reading.
So a street vendor earns $60 selling 2 varieties of cabbages. Green cabbages, which sell for $4 each, and red cabbages, which are $6 apiece.
Very good.
So A, we're going to write an equation to represent the relationship between the number of green cabbages, X, and the number of red cabbages, Y, sold.
Very good. So we're going to stop here for now. And again, we've talked about this idea that mathematicians love to use X and Y by default, so we're going to get familiar using it. Pause the video, take 30 seconds. Give me an equation that represents the relationship that we've got above. Go. Alrighty, maybe you got it, maybe you didn't. What do you think, Mommy?
I think we should keep going.
Well, I want to write the equation.
Oh, what the equation is.
Yeah.
So you are stretching my brain because I haven't done this in
Okay.
30 years.
So we're
let me take a look.
Yeah. So we're using X, right, to represent the number of green cabbages. If you have X green cabbages and they sell for $4 each, how would you represent the cost that you get from your green cabbages?
So X times however number of cabbages you have.
Right. So you would do 4 for the number of green, or for the amount per green cabbage. Multiply that by the number of green cabbages that you get. That gives you the total amount of money from green cabbages, plus the amount of money from red cabbages would be
Y, which is equal to 6 times however.
Y isn't equal to 6, right? We're saying Y is the number of reds. We have $6 per red cabbage. So if I multiply 6, which is the amount per, times Y, which is the number of.
Yeah, now it's coming back.
Yeah, so there's 6Y. And then when you add these together,
you get 4x plus 6y, which is equal to...
How much do we get in total?
It's been a while.
What does it say on the problem? A street vendor earns how much?
Earns 4 for each.
No, a street vendor earns?
$60.
$60.
Oh, I'm so sorry, I missed that
There
part.
you go. Cool. So 4x plus 6y equals 60 is our equation. Yeah?
Got it.
Cool. Part B?
Part B. Using a table, list at least 3 possible combinations of values for x and y that satisfy the equation you wrote.
And C?
Write each of your combinations above as an ordered pair and graph them on the Cartesian plane. What do you notice?
Very good. Can you tell my mother is a teacher? She's using her teacher voice. So, now that you've got your equation above, the idea is that we want to find some pairs of values for x and y that satisfy, or in other words, make true, the equation that we wrote above. Give yourselves 2 minutes, 3 minutes, play around, pause the video. Give me at least 3 pairs of x and y that you've got, put them on the Cartesian plane, and once you do, I want you to tell me something about what you notice when you plot those on your graph. Go! Alrighty, Mommy, you ready?
I'm ready for you to tell me.
Let's do it. So, I wouldn't expect you necessarily to have any of these, but I'll give you an example of one of the ones that you might have found. So, if I sold 0 green cabbages and 10 red cabbages, then this would be an example of something that would work. If I wanted to check my work, do you remember how we would check to make sure that this is actually, in fact, a solution?
I would actually insert those numbers into x and y.
Ha ha ha, very good. You're better than some of my students. So what I would do is I would take the 4, right? Every time that I see an x, I'm going to replace it with a 0 plus 6 times. Every time I see a y, I'm going to replace it with a 10. I just need to see, is this equal to 60? So walk me through the simplification. How do you know?
So 4 times 0 is 0.
Very good.
Plus 6 times 10 is 60. So 60 is equal to 60.
Very good. 60 is equal to 60. This is indeed a solution. So we're not going to check for all of these, but I'll give you some more. If you don't believe me, again, fact check me. You can plug in on your own. 3 greens and 8 reds would work. 6 greens and 6 reds you might have found, we can keep going, you might have found 9 greens and 4 reds. You might have found 12 greens and 2 reds. Then you could even keep going to the point where you plugged or got 0 reds, then you might have had 15 greens.
So, son, how is it that you came up with these numbers?
I used Desmos.
Ah,
I'm the teacher. I just know what they are.
okay.
But they would find it through trial and error.
But how would I find it exactly? Through
Yeah,
trial
so
and error.
in
I
this
would
case,
keep
right-
plugging in numbers.
Yes. So the
Until I
idea
got it.
is that you would use trial and error to get this. But, of course, hopefully you realize that that is not a particularly effective solution. So the
No.
whole point of this lesson is to figure out, well, is there a more efficient way for me to come around to getting these rather than just guess and check, plug and show?
Amazing.
Cool.
Let's keep going.
So now that I've got these, part C asked me to write them as ordered pairs. Do you remember how you'd write x equals 0, y equals 10 as an ordered pair?
Isn't it a comma in between?
Yeah, it's a comma, and then around it,
Parentheses.
good. So you've got 0, comma 10 as your ordered pair, and then on the graph we need to plot these. So I'm going 0 in the x direction, 10 in the y direction. That points right over here. Do you remember why the 0 comes before the 10, Mommy?
Because it's the x value.
Yeah, but why does the x value come before the y value?
I do not remember why.
It's arranged in
X, Y.
alphabetical order.
Got it.
Yeah, okay. So then 3, 8 as an ordered pair. You've got 3, comma 8
Wait,
in parentheses.
I got this.
Oh, you want to write for
So
me?
we got 3. We're going to come over here to 3.
Okay, very
and
good.
then we have to find 8, which is up here.
Yay.
So that would be my plot.
Oh, thank you.
Oh, my circles definitely
How-
don't look as good as yours.
Listen, you said it, not me. So then 6, 6. Got 9, comma 4. 12, comma 2. 15, comma 0. Fantastic. And then as my lovely mother did, right, all of these would go on the number line. So 6, comma 6 would be over here. Next up we had 9, comma 4. Not going to have room to put the 15, comma 0 that we had, but the 12, comma 2, right, it's not totally on my number line on the x, but it would be right over here. Fantastic. So now that we've plotted all of these points, maybe at home you've noticed the more of them you plot. Can you, Mommy, make a conjecture? Like, what does it seem like these points are doing the more of them that I put on my Cartesian plane, my graph? What does it look like is
appears that they're
happening?
making a straight line with a negative slope.
Ooh, okay. Well, we don't know anything about slope yet, but if I were to imagine connecting all of these points, yeah, I think I would certainly notice the same thing. The more of them we plot, the more that this seems to look more and more like a line. Cool. Good observation. Hopefully you made that observation at home. So we've got this Cartesian plane, and while the Cartesian plane can, of course, certainly be somewhere where we're just plotting points at random, its true value lies in the fact that we can use that plane, as we just did above, to collect solutions to our equations in 2 variables. In doing so, we create this thing that's called a graph. And by definition, right, a graph of an equation is just going to be us plotting all of its solutions. So we say that the graph of an equation, by definition, is the set of all ordered pairs. Mommy, do you remember by definition, what does a solution do? What does a solution
I'm assuming
do?
it draws your line for you.
Yeah,
Makes your line.
in this case it is going to make a line, but by definition, to solve an equation means to make it.
Equal on both sides.
Yes, in other words, you're trying to get to a statement that is.
Equivalent.
Yes, another word for equivalent.
Equal?
True.
True, yes, of course.
Everybody at
true.
home is screaming at you because we do this like once every class. I ask them what does it mean to make an equation true.
Oh,
So
my goodness.
that's fine. So now that we know that by definition a graph of an equation, it's the ordered pair that makes the equation true. Mommy, what does that mean? Hopefully you might notice about what a graph actually is. Oftentimes mathematicians tend to forget this. But if a graph is just me putting all of my solutions there, what is the graph actually?
It's the relationship of your x and y.
Yeah, right? It's the collection of everything that makes it true. In other words, it is the set of my solutions, which means at the end of the day, the graph is just a visual representation of the solution set. When we're graphing, we often forget that the line in this case that we're going to draw, any point on the line, if I take its coordinates and plug those in for x and y, will make the equation true. Sometimes we just think it's just the points that we find, but no, in fact, anything on the line will make the equation true. So the graph is a visual representation of the solution set. Yay! In Algebra 1 and beyond, a lot of our exploration is going to be in some way connected to the graphs of equations. Being able to solve them is cool, but something about seeing them allows us to, say something that's really powerful. We'll get into a bunch of different types of graphs later in the year, but for now we want to focus specifically on graphs of linear equations. Mommy, do you remember by definition what makes an equation linear?
I do not.
Okay, well take 5 seconds, pause the video. What makes an equation linear? Go, 5, 4, 3, 2, 1. Emphasis on 1, because by definition, a linear equation is an equation where all of the variables have an exponent of 1, right? Quadratic equations, for example, we'll talk about later in the year, have like x squareds, y squareds. Here, everything is x to the power of 1, y to the power of 1, z to the power of 1, whatever. So that criteria is super broad, though, which means that linear equations can come in a bunch of different forms, each of which serves a different purpose, and sometimes that purpose is just to look scary. But in that sea of options, mathematicians said, hey, we need a basis, we need somewhere to start, so they came up with what they called the standard form of a linear equation in two variables. Now, I wouldn't expect you to know what it is, but the general form of our standard form always looks something like this. So capital A times lowercase x plus capital B times lowercase y equals capital C. Now these things, the A, the B, and the C, in this equation they're standing in for variables, and those variables, they are just going to be numbers. In fact, A, B, and C are going to be a particular type of number. They're all going to be integers. Mommy, do you remember what an integer is?
Integer is a whole number?
Kind of, yeah. So it's a whole number or a negative number or 0. Okay. So anything that does not have a fraction or a decimal is an integer. If you're interested, by the way, remember that we have that bold letter R that stands for the set of the real numbers. The set of integers is represented by the bold letter Z. It comes from a German word which means integer. I don't speak German and I don't remember what it is, and even if I did, I would butcher the pronunciation. But there you go, that's your symbol for the set of integers. And this x and y, of course, these are just going to be the variables x and y that we're familiar with. And you haven't realized it, but in fact, every single linear equation that we've been working with since the start of this unit has been in standard form. Remember the one that we did above? We said 4x plus 6y is equal to 60. Notice this one is in standard form. I've got 4, 6, and 60, no decimals, no fractions, and then my variables x and y. Last time we were together, we saw x minus y equals 7. This is also in standard form. And then we also last time worked with the equation 9x plus 2y equals 15. So all of these are in standard form. And from our exploration above, we should feel really good about saying what the graphs of any linear equation should look like. Mommy, as we saw, what is the graph of any linear equation going to be?
A line.
A line, very good. So the graph of any linear equation will in fact be a line. And we'll also say, and vice versa. And the idea for that being that if I were to draw a line, there is exactly one linear equation that matches with it. So any linear equation corresponds to exactly one line, and every line corresponds to exactly one linear equation. Cool.
Awesome. Let me interject here that I am a third grade teacher. So I apologize for all of my forgetfulness. There we go.
I apologize for all of her forgetfulness too. Okay, so that's cool. We know what a linear equation is by definition, but how do we actually go about graphing it? Well, if I want to graph something like x minus y equals 7, we're going to come up with, as we often do, a procedure for graphing an equation like this. But take a minute, pause the video, think about some things that you might want to use to orient yourself as you're trying to find some points. And I'll give you a hint. As we saw above, just simple plug and chug is not going to be our most efficient method. So what strategy might you want to use if you want to think about making this process move a little bit more quickly and a little bit more intentionally? Okay, take a minute, pause the video, game plan, see what you come up with. Have fun. Okay, so mommy, help me out. See what you remember about graphing lines. Let's say that I want to come up with a procedure to make my life move a little bit easier. What might your strategy be?
Well, first thing I do is I would set up my chart, my T-chart with my X and Y.
I like that. So there's a method to the madness here. I don't just do things all willy-nilly. Sometimes I do, but for the most time I don't. The first thing I usually want to do, we're going to pretend that this is a nice straight line, is make a table of values. So my first thing, right, I'll write it down. I want to make a table for my x values and my y values. Now, I'm actually going to take this chart and expand it a little bit. What I like to do, and I'll move this over here just to make things look a little bit nicer. I want a table, and on my table, I'm going to give myself 3 components to it. So first of all, I want somewhere where I'm going to keep track of my x values, somewhere where I'm going to keep track of my y values. And then what I often like to do, if you don't want to, you don't have to, but for me, I like to remember that they are connected by the equation x minus y equals 7. So I put that in the middle as my sort of connector tissue. Great. So I've got a table of values for x and y. Now that you've got it, what might you want to use it for?
What I would do is I would leave x on one side, move y to the other. X is equal to 7 plus y.
Ah, okay. So I like that strategy. In this case, though, we're thinking in terms of efficiency. So before we get to that strategy, let's try something a little different. But I like your approach. So absolutely, you can make any choice that you want. You can rearrange your equation to make it look like whatever you want it to look like.
So in the x 1 through, what do you have there, 10?
Yeah.
Label it 1 through 10 for x.
You could.
Right. And then what I would do is I would add 7 to that to get my y.
Okay, so if I'm thinking here about like how I want to find values of x and y, again, the logic is just simply plugging in values at random isn't going to work. So I like your strategy, right? If I plug in a value for x, I can see what the values of y are that are going to work with it. So my step 2, do you remember, Mommy, by default, how many points you want to include on your line?
You need a minimum of 3.
Good. So you want to find and plot at least 3 points. Do you remember why you want that 3rd point?
I want to make sure it's not a parabola or a different shape.
Yeah, right. So we want to use our 3rd point as like a check. So if I get a 3rd point that doesn't live on the same line as the other 2 points, I know I've made a mistake somewhere. And the strategy, as we've talked about here, right, if I plug in a value for either x or y, then that should give me a fail-safe way to arrive at the other value that I need to plug in together to make it true. So I'm going to use substitution to find this. So I like your strategy. Plug in values for x and see what values of y we get. If we're thinking strategically, what is the easiest number to plug in for x?
1.
Even easier.
0.
Yeah, let's do it. So I think by default, the easiest number to start with is by plugging in 0 for x and 0 for y. We're going to come up with next class an actual fancy name for these points. But when I plug in 0 for x, let me not cut this off yet. How would I find the value of y, Mommy?
So now 0 is equal to 7 plus y. That means that 7 plus y has to equal 0, which means y is negative 7.
Fantastic. Right, so if 0 minus y equals 7, all I need to do is substitute the value of x in for 0. 0 minus y, right, well, I can ignore the 0 functionally. This becomes minus y equals 7. If negative y equals 7, then y equals?
Negative y is 7?
Yep. If negative y is 7, then
And
positive
y is
y.
7.
No. If negative y is positive 7, then positive y is?
Negative.
Negative 7. Good. There you go. So when 0 is x, y is negative 7. So now that I've got this, what does that tell me about the point that lives on my graph?
It is below your x.
Yes, right? And specifically the ordered pair that corresponds to this point would be?
0, comma, minus 7.
Very good. So the point 0, comma, negative 7 is right over here. And then, as we saw in class last time, often like to label our points on the Cartesian plane. Cool. Let's do 2 more. So next easiest number to plug in would be 0 for y. So I'm going to take the 0 for y. Again, you don't need to plug in zeros or values just for x. So I'm going to take x minus 0 equals 7. Help me solve my equation.
So x would now become x is equal to 7 minus 0, which means x is equal to 7.
Yeah, x is equal to 7. So when y is equal to 0, x is equal to 7. So the ordered pair that corresponds to this value would be?
7 comma 0.
Very nice. And then I plot my point. 7 comma 0 is right over here on the x-axis. And then finally, again, we're making our lives smarter, we're thinking smarter, not harder. We're making our lives easier. Give me something easy to plug in. So either x or y, what would be a nice number to plug in?
I would do x4.
x4, you could do 4. I think 1 is probably the easiest number to plug in, but since you gave me 4.
The reason I'm thinking is it's halfway between these 2 points.
Sure, I like that.
X.
Okay, well then let's plug in 4 for x. So then we would say 4 minus y equals 7. Solve for y for me.
4 is equal to 7.
No, I'm going to solve for y.
Oh, solve for y.
Yep.
I'm so sorry. So
You're good.
minus y
Not minus y, right? If I'm trying to get y by itself, I have a 4 connected to the y, and I have a minus sign connected to the y.
So I can move y over. So 4
Okay.
minus 7 is equal to y.
Okay, so you're going to add y to both sides.
Mm-hmm.
So then you get 4 is equal to 7 plus y, and then to get y by itself,
Y is equal to 7 minus 4.
other way around. But yeah, right? So I would subtract 7 from both sides. So you have 4 minus 7, which is negative 3. And y is equal to negative 3. Cool. There you go. So when x is equal to 4, y is equal to negative 3, the point, therefore, that's on my graph would be?
4 comma minus 3.
Very nice. So then 4 is over here. Go down 3 in the y direction. 4 comma negative 3 is right there. Cool. So now I've got my 3 points. And now that I've got my 3 points, one last thing for me to do. We said that the graph of any linear equation is a
Line.
line. So what's the last thing I should probably do?
I should probably graph it.
Okay.
Can't speak. Connect the dots.
Yeah, there you go. Connect the dots. So the last thing that we're going to do, we're going to connect our points with a line.
So much for math language.
I know that I'm funny, but you don't just need to laugh at me. You're going to make me cry. Okay.
No, I'm laughing at me for saying dots instead of points.
That's fine. Who cares? Cool. So I'm going to connect my dots, right? I'm going to draw a straight line, or as close to a straight line as I can manage on a wonky iPad, through my 3 points. Yeah, thank you. Okay. So now that I've got my 3 points, right, the other thing that I'm going to do, remember, I often like to include arrowheads when I'm graphing here to indicate that my line extends beyond the boundaries of the graph that I've drawn. Yeah, cool. There we go. There's our graph of x minus y equals 7. So we've got our 3-step strategy. Shall we do one more for the road?
Sure.
Okay.
Bring it on.
One more. Negative 2x plus 3y equals 6. So again, 3-step strategy. I want to build myself a table for my x and y values. I want to find and plot at least 3 ordered pairs on my Cartesian plane, and then I want to connect my points with a line. Give yourself 2 minutes, 3 minutes, pause the video, play around, see how far you get. Have fun. All right, let's do it.
Let's do it.
Walk me through.
Okay, first thing we're going to do is we're going to set up a chart of 3 columns labeled x minus 2x plus 3y is equal to, your hand's in my way, 3y is equal to 6.
Skill issue. And finally,
y.
Very nice. So somewhere to keep track of my x values, somewhere to keep track of my y values, and then I often like to put my equation in the middle so that I know what I'm slotting into. Great, I've got my table set up. Now how am I going to use it?
Lovely, if I can remember how to do this.
Okay, so again, my strategy is going to be?
I'm going to isolate x by itself.
I wouldn't even. I think before we get there, so you're kind of predicting the future where we're going to go, which I love. I think that's amazing. But for now, we just want to get familiarity with using our equation as it is and substituting in. So, if I'm substituting in, easiest values for us to plug in are?
0.
Zeros. So we're going to start by plugging in a 0 for x. If I plug in 0 for x, then this would become, right, negative 2 times 0 plus 3y equals 6. So help me solve for y here.
Okay, so minus 2 times 0 is 0.
So this just becomes 3y equals 6.
And y is equal to 2.
Very good. How'd you get there?
Because I divided by 3 on either side.
Lovely.
Y is equal to 2.
There you go. So y is equal to 2. So that tells me the point 0, 2 is on my graph. I'll go ahead and put it there now. Where does 0, 2 live on the graph?
0, 2 lives. I'm going to find my 0, which is here. And then 2 on my y will live right there.
Very nice. So here's our point 0, 2. Let's find 2 more points to plot on our line. Next easiest thing to plug in would probably be?
Y is equal to 0.
Very nice. 0 for y. So now I've got negative 2x plus 3 times 0 equals 6.
Okay, so now we solve 3 times 0 is 0. Minus 2x is equal to 6. Now I'm going to divide by minus 2 on either side.
Very good.
So x is equal to minus 3.
Nice. So negative 3. Who says that a 3rd grade teacher can't graph a line? So we've got negative 3 comma 0. It's me. I said the 3rd grade teacher can't graph a line. Negative 3 comma 0. And then finally, so again, we're trying to think quality of life. Try and find an easy number to plug in for either x or y.
1.
Okay, and do you want to choose y or x to plug in for?
Let's do x.
Cool. So we can plug in x for 1. So we'll say negative 2 times 1 plus 3y is equal to 6.
Now, just a little stop here. Would it have made more sense to use minus 1?
No, not necessarily.
Because then we... Okay.
I mean, you could do whatever you want.
All right.
It doesn't matter. Okay, so let's say that we use the positive one.
Nope, let's use it. Yes, the positive one. Sorry.
Right.
Go. So now I have minus 2 plus 3y is 6.
Okay.
I'm going to add 2 to either side.
Very good. Again, reverse order of operations. Easier to get rid of our addition and subtraction than it is to get rid of our multiplication and division. 6 plus 2
3y
is
is equal to 8.
8. Very good. Last move.
Now I have to divide by 3 on either side. So y is equal to about 2.6.
Yeah, we're going to leave it as 8/3. So yeah, it is about 2.6. So if we're trying to plot that on the xy plane, so when x is positive 1, that means y is going to be, if it's 8/3, about 2.6. What two numbers does it need to be between?
Wait, repeat that. I was looking at the graph.
Yep, so it's 8/3. It's going to be between what two numbers?
8/3 is going to be between 2 and 3.
Very good. Is it going to be closer to 3 or closer to 2?
It's going to be closer to 2.
Well, you said it would be 2.6-ish?
2.6.
Yeah,
Oh,
2.
to 3.
Yeah, so
Did I say
2.6.
6? Oh my goodness.
So there you go. It's going to be like somewhere here-ish. So then here's your point, right? Maybe I'll move that 0, 2 over. So we'd say that the 0, 2 is somewhere over here. And then we have 1, 8/3. I've got my 3 points. All I need to do is...
Connect the points.
Very good. So I'm going to
I
draw...
learned a new word today.
Yay. So we're going to connect our points. Last thing I need to make my graph correct. So I've got my line.
I have to put my arrows on either side to show
Very
it
good.
is continuous.
Beautiful. That's it. Congratulations. We graphed negative 2x plus 3y equals 6.
Yay!
Yay. Alrighty, my friends. Thank you for bearing with me. I know this was probably way longer than 15 minutes, but listen, you got to listen to my mom. So congratulations. Mommy, anything that you'd like to say as we say goodbye?
It's coming back. It's coming back slowly. And actually, if you sit through and work it through, I probably could have done this without guidance.
Cool.
I'm sure that they can do it too because they've been exposed to more than I have.
Yay. I love
Yay.
it. Any advice before we say goodbye?
Keep practicing. Practice makes progress.
Gotcha. You're not going to say how good of a teacher I am or how lucky you are to have me
Well,
as a
I
son.
think they already know that. But they
Aw.
don't know how lucky I am to have him as a son. And yes, I am very lucky to have you as a son.
Aw, you don't have to lie to make me feel better. It's okay.
He didn't pay me for that either.
That's okay. She's going to take it out of my bank account later. Alrighty. Thank you, my friends. Have a lovely rest of your day. Take care. Be good. Goodbye.
Bye.